I see a few more people have shown up, so not to backtrack, but just for the bump of folks that just showed up a few minutes after the hour. Thanks again for joining us here today for our industrial white paper review. In this presentation, we're going to take a look at some real-world applications for our PDW wireless systems, talk about what those products are, what they can do, and try to leave you here with a general understanding of where and how you'd use them. I have a few people reporting my audio isn't very good, so if you're finding that as well, please go ahead and let me know, and I'll try to make some improvements. With that, there's a few things I always like to begin with, and that's to answer everyone's first question, which is, can I get a copy of the slides today, or is it possible for me to get a video recording of this presentation? And the answer to both of those questions is yes. You'll have a copy of the slides sent out. You'll also have a copy of today's recording sent out as a video, and all of that will come with an email you'll get probably by the end of the week. In addition, the other question that we get a lot is, well, can I talk live on the webinar? Can I ask a question? And unfortunately, no. You've probably noticed you're in listen-only mode, and that's because there's just too many people on the presentation today for us all to have a bunch of open phone lines. However, if you want to give me some feedback or if you have questions, then please go ahead and type those into your webinar chat box or into the questions and answers button, and you'll find both of those in your Zoom toolbar. I'll pause periodically to try to do my best to answer those. If you have a question that's too difficult or too long to answer live, though, we'll do some follow-up with you after the presentation. Lastly, if you could do me a personal favor, we have a survey that may pop up at the end of today's webinar, and that helps me craft future presentations. Lets us know what kind of topics you are interested in. And so if you could fill out that survey, it would sure be appreciated, because it's one of the only ways we get feedback here, and that helps us provide better presentations for folks. So with that, why don't we just jump on into today's presentation? I'll turn off my video, so I will talk to you later, but probably not see you. And we're going to focus our attention here on the slides for today's webinar. First of all, allow me to introduce myself. My name is Joe Ryan. I'm the VP of Sales and Marketing with Precision Digital, and I've been with Precision Digital now for almost 20 years. And I've seen these kinds of products from both the engineering side and on the sales and use side. So I've been out in the field, I've installed these products, I've made sales calls to sell these products, and I've designed them. Puts me in a nice position to have conversations with folks like yourselves about what they are and what they do. In today's presentation, my goal is to review the contents of that newly released Go Wireless white paper. And if you have not seen that white paper, I'm happy to send you out a copy of it. Just let me know that in the survey that you'd like us to send you that either as PDF or in print copy. We're going to discuss the problems and solutions that are involved with upgrading existing systems where you might want to end up using a PDW wireless system. What are the sorts of reasons you choose it, and what does it solve? Then we're going to look at some real-life applications with some site maps to show examples of how people have used our PDW wireless systems and what the problems were they were solving. And we're going to see some application examples in a simplified version that are used to help illustrate what these products can do for you. And we'll quickly review the products themselves, see a couple of nice features, give you pictures of what they look like. So let's start off with trying to answer the question, what are the problems you're going to run into that a PDW wireless system could help solve? So the main issue that we see when people use PDW wireless systems is that they're trying to run new wires, either to build a new system or to upgrade an old one. And it usually involves trying to lower the costs of doing that installation, right? The most common thing I run into is digging trenches. You don't want to have wires flying over your parking lot. You want to keep things buried if you can. And whether it's because you can't trace the old lines easily or it's because you're putting in something new, digging trenches is just hugely expensive. It's a lot of time and money. It has just all kinds of hidden expenses, right? Repaving, getting the equipment, having the guys work on it. That can be more expensive than the actual equipment you're installing. If you're, especially on an interior application, if you're doing this indoors, running hundreds of feet of wires can be really, really economically not viable. If you have to run wires through multiple levels of a facility, if you're disrupting office environments to try to get this stuff installed, if you have to hire specialty contractors, that's a real problem. And once again, you might run into the case where running this 300 feet through your facility could end up being more expensive and take longer than the actual installation out in the field. And that's a real problem. Excuse me, had to sneeze. And then the rat's nest you find when you start these projects is that number 3 example. There are all sorts of applications we've seen where people think it's going to be an easy job to run a new pair of wires, or they have a break somewhere in their wires, their signals just aren't working and they have to trace them. And all of a sudden you find out everything is a mess. You just can't seem to figure out where the wires go. The wires, the loop splits off in 2 different directions. Things are filled with water, and now you got to figure out how to repair the pipes. It can be a real problem. And in any of these situations, a PDW industrial wireless system helps you solve those problems. Now, what do you get when you go with a PDW wireless system? Well, to be clear, what you're doing is you're transmitting analog, aka 4 to 20. That's 4 to 20 milliamps. Discrete signals like relay closures, float switches, flow switches, things like that. And Modbus signals on RS-485 wirelessly. These are a wireless bridge product. So you bring in physical signals that are either 4 to 20 milliamps, discrete, or Modbus, and it comes out the other side as a physical signal, a 4 to 20 milliamp, a discrete closure, or an RS-485 Modbus. So to everything else in the system, they're not even aware that this has happened. And these can transmit things in 2 directions. Oftentimes people ask me which one's the receiver and which one's the transmitter. And while that may make sense for your specific application, in reality, I can have a 4 to 20 milliamp signal going in one direction. I can be sending 2 relay contact closures going in the other direction. And I can have them just sharing a back and forth RS-485 bus. There is not just one direction between units that these signals can go. You can send and receive those analog, discrete, and Modbus signals. It's important to know the range of the product. And for these, we have a pretty conservative range statement of 1 mile outdoor line of sight or 500 feet indoors. And the reason we do that is that we're confident if you install it and you have that 1 mile outdoor line of sight or 500 foot indoor range, that you're going to get a connection. Of course, it's not a guarantee. You try to install these things underground in some kind of sealed metal enclosure. Yeah, okay, you're going to have real problems there. If you're trying to run it through a generator, okay, you're going to have issues. But for the most part, if people use some common sense, these are very attainable ranges. Some people have managed longer, especially with Yagi antennas, things like that. But this is what we feel confident standing behind with our standard antennas. And the real reason you're doing this, the real feature that makes you care about the PDW systems, is that you're saving on time, manpower, and cost. You don't have to deal with that rat's nest of buried wires. You don't have to run new cables through their building. You don't have to trench your parking lot. We're a way for you to get those signals from point A to point B without having to do any of that for a relatively low per point cost, especially when you consider all those installation costs, if you're not just talking the price of equipment. So with that having been said, let's look at what we're really here for, which is these real-life applications that are going to show you how people have been using the PDW wireless systems. This is an application to transmit process signals to a SCADA system in a wastewater treatment plant. And they did this with our PDW-90 wireless system. So walking through what they needed here, the operators needed to monitor process information on the SCADA system from the control room. And that control room is located here at location B. That is their central building, and that is where they have their SCADA systems PLC. That's where they have their monitor screens to look at. That's where everything revolves around. And they had a collection of different signals that they were trying to do this with. It wasn't all just one type of signal. So they had 2 4 to 20 transmitters. They had a chlorine storage tank that had a level transmitter on it, and they were doing open channel flow measurements with a level transmitter. And both of those were 4 to 20 milliamp signals. And if you look at our map here, that was 1 and 2. So they're near each other, but not on top of each other. And one was actually across a roadway. Then they had a bunch of discrete signals, these on-off signals. They had an aeration building blower status over here at 3, and that's just an on-off status indicator. Same with this pump station status location, which was on the whole other side of the plant. And then most troublesome, everything we've looked at so far is over here on the east side. But over here on the west side of the plant, they also had these compost blower status indicators they wanted to bring back. So now they got 4 different locations with 4 different discrete signals, all on the other side of the facility. So for them to actually hardwire this up, they would have to run wires literally the whole run of this place. And obviously that just wasn't something they were going to accept. So they were out looking for solutions, and they found the PDW-90. And so here's some pictures of the actual installations of those PDW-90 systems. They took our rugged field units that come with mounting flanges, so they're easy to mount, and they put them up high, outdoors. There's one mounted on the storage building. Here's one over by the open channel flow unit. And they just bring that 4 to 20 milliamp signal up and into their field unit. Now, before I move on from this one, I also thought it's good to point out that they also put a PD6000 panel meter mounted in a box right outside the storage building. So they'd be able to see from outside the building what the level status was of those sodium hypochlorite tanks. So that's a great idea. If you're going to run these 4 to 20 milliamp signals outside your buildings anyway, you might as well give people what the information is they want to know before they head on inside on a external box mounted with some kind of a display, a PD6000 or 9000, depending on how many signals you're talking about. It's a great choice. I also recommend our PD2 Helios large display unit, because then you can see it from 100 feet away, and you don't even have to be at the building. Now, looking at some other installations there, the PDW-90 field units have a range of 1 mile outdoor line of sight or 500 feet indoors. So they're attempting, they did their best to mount these PDW-90 field units up high, keep those antennas in line of sight. And their PDW-90 was mounted inside their control room, just to an exterior facing wall. And the PDW-90 base station, that's this box right here. So you've got your field units, which are those blue boxes with the antennas sticking out. And then you've got your base station, which is this plastic box. And you can see they angled the antenna so it would actually be looking out the window, hoping that that would help with their line of sight. None of these distances were 1 mile. And they were able to make all of these connections just fine. The nice part about this too is they were able to do it with the standard antennas. They didn't have to mess around with mounting antennas on the roof or going with Yagi antennas or any kind of dish. Our standard antennas that come pre-attached to the field units and that you just mount wherever is convenient on the base station, we're able to do this connectivity for them. Once they had those signals turned back into physical signals into the control room, then they just bring the 2 4 to 20 milliamp signals and the 6 discrete outputs back into their SCADA system. And again, to the SCADA system itself, to that PLC, and to the transmitters out in the field, this changeover to a wireless connection is totally blind. They have no idea that's happening. One side's outputting a 4 to 20, the other side's receiving a 4 to 20. Doesn't matter that we're doing it wirelessly in between to anything. There's no programming they have to do on the PLC side or any settings or concerns about the transmitter side. We're just a wireless bridge. We bridge the connections between 2 wires. Now, before I move on from this application, I do want to touch on a question I got here from David, which is there any limitations with the number of devices to avoid signal interference? Well, first, let me talk about the number of devices. A PDW-90 system with a base station can connect up to 32 field units. Now, that doesn't mean that you've got the ability to do all of the capabilities in those 32 field units, but if all you're talking about is a 4 to 20 milliamp signal, then a base station will support 32 field units, each one transmitting a 4 to 20 milliamp signal. If I was doing a 4 to 20 milliamp in, a 4 to 20 milliamp out, and a couple of discrete I/O back and forth from that field unit, then I couldn't support 32 field units, probably be more like 8 or so. But it all has to do with how you populate the base station, and we'll see that a little bit later. Now, that's not really your question. Your question is, how many of these devices can I have to avoid interference? And you don't really have interference issues with these. It's a 900 megahertz spread spectrum or frequency hopping spread spectrum signal, which means that the signals are constantly syncing up and jumping around to different frequencies around 900 megahertz as a band. So they're not all transmitting on one specific fixed frequency. They jump around, and even if one finds a conflict, they very quickly then change over to the next frequency, which is going to be different, and the two aren't going to collide anymore. So I'm certain there is an answer to your question. There is some technical point at which these cannot connect, but it's a very, very large number that you're not going to run into. And then another interesting question that came up was someone just trying to clarify what I said. Can I pull signals into a PLC before going into SCADA? That's an interesting question, Megan. And so it all depends on how your system is set up. As far as our product goes, the PDW wireless system, we take in a 4 to 20 and we output a 4 to 20. Now that 4 to 20 signal may go to a PLC. It may go into some other device connected to your SCADA system. It may go through both. It may go through panel meters. You can do whatever you want to with that 4 to 20 signal once it comes out of our base station, or that discrete signal once it comes out of our base station. There's all kinds of options there. And that really just has to do with how your system's designed. It's also worth noting, Rob asks, do we have a survey kit that can be borrowed to make sure that this is actually going to work? And the answer to that is yes, we do have a survey kit. And so we have a PDA 10 you'll see a little later. And if you wanted to take that and you set one up at your SCADA system location and then wander around the plant and sort of see where you could hook these up, that is absolutely what that is intended for. And we'll talk more about that in a little bit. And the last question I'm going to touch on before we look at our second application here is from Khalid, who asks, we can transmit 4 to 20 milliamp and status signals. How about signals from flow meters, like pulses that you get out of a mag meter or mass flow meters? Really what he's talking about is high-speed pulse outputs, and we cannot transmit those. The discrete outputs are really not, the discrete I/O is more designed for switches, like flow switches, level switches, things like that, relay contact closures for turning on pumps or lights. It's not a high-speed, high-frequency output. So in those cases, what you want to do is get yourself a pulse input meter, for example, Precision Digital's PD6900 series of products. And I believe we have a P6938 that would be what I would recommend for that. Take in that high-speed signal and then output that as a 4 to 20. And realistically, you don't want to be running those high-speed pulses long distances anyway. They're very noise susceptible, especially the very, very low millivolt signals. And so you're probably best off converting it to a 4 to 20 milliamp as close as possible to the flow meter anyway, because you wouldn't want to run that pulse signal outside, up a wall, and to wherever you're going to mount your antennas. You really would want to convert it to a 4 to 20 milliamp signal or to a Modbus signal as fast as you can, as close as you can to your flow meter, just to keep it accurate. So with that, let's, I know there are a couple other questions coming in, and we'll touch on those after we're done the next application example. And our second application is also at a wastewater treatment plant, but this is sort of a unique one, talking about primary flow calculation. You see, in this example, the wastewater treatment plant is trying to run an auto sampler that's on their primary flow inlet. And the problem they have with that is that they have already got flow meters and sensors that will give them the information at their secondary inflow. So they got their primary flow calculation they're trying to perform back here at their control room. Then they've got their secondary inflow location down here, and they've got flow meters on that. They know what's going on there. And they've got their final effluent gauged up. They know what's going on there. So they know how much they're putting out. They know how much the secondary inflow is taking in, but they don't have any measurements on the primary inflow location. And for various reasons, that really isn't something that they wanted to do. Now, they'd love to be able to take that secondary inflow, take that final effluent, and do some math with our PD 9000 Consolidator Plus to come up with that primary inflow calculation. And then based on the primary inflow totals, run an auto sampler. And we can certainly do that with the Consolidator Plus, but somehow they have to get all these signals into one place to do that math. And so what they did is they used our PDW90 system. And in this case, they put remote antennas. They mounted a PDW90 field unit inside the building, and then ran to the exterior a antenna extension cable, which then connected up to a Yagi antenna to boost up their signal. And they just put that coax cable to the antenna extension cable right through the wall. Now, did they need this Yagi antenna? That's a good question. I can't say that I know they did. However, they were trying to get through some trees, and trees are tricky for wireless signals. And so they thought that they'd be all right going with a directional Yagi antenna. And so they just installed that right from the get-go, and everything worked. Did they need it? Can't say for sure, but they figured better safe than sorry in this application. Then at the other location, they again connected their PDW90 field unit inside the building, and then ran an antenna extension cable outside the building up to where they connected it to a Yagi antenna. Now, in this case, again, I can't say they needed it for sure. They were only going 150 feet, but they had real concerns about the fact they were trying to cut through another building to get there. And so again, they figured better safe than sorry. Let's boost that signal up with a 9 dB Yagi antenna. And you can see where trying to get it back here to this B location, which I just scribbled out, so let me clear that. Trying to get the signals to the B locations, they've got to go through some trees in one direction, and they've got to go through a building in another direction. And so that's why they chose to go with those Yagi antennas. Happy to say it worked with them. That's perfectly great. Don't know that they actually needed it, but sometimes you want to be safe. You don't want to have to go back and do it again. Then at the primary flow calculation location, they brought those signals from our base station unit back out as 4 to 20 milliamp signals and into the Consolidator Plus. The Consolidator Plus did two things for them. It took in those 4 to 20 milliamp signals and did that flow calculation so that they could figure out what the primary inflow was, which then allows them to do totalization on that and trigger the auto sampler via one of the relay outputs from the consolidator. But it also gives them a phenomenal looking display for all that information. And you see everything gets labeled nicely. The screens are labeled. Each individual channel on the screen is labeled. They've got units they can look at. The digits look great. And it's worth noting, one other thing they got, they didn't just get that mass and the display. They got the fact that now they can data log all this information. The Consolidator Plus has a USB data logger on it. And so they got the ability to have all of this in a USB stick on the back of the consolidator that they just pull out, walk away with, take off the USB stick, whatever they want, put it into Excel. So this was a nice solution for them that to do via wired connections would have cost them a small fortune. Then on top of that, you put on the Consolidator Plus, and now they've got a great little display doing their control elements for the auto sampler. Let me address a few other questions that have come in. Does Precision Digital sell a wireless bridge that can transmit videos from security cameras, even if it's just photos? We don't do that. As you saw in all these examples, we deal primarily in process signals. So 4 to 20 milliamps, discrete signals, RS-485 Modbus. In theory, we can take in 0 to 10 volt signals, but the output is a 4 to 20. But we don't do Ethernet connectivity. We don't do live video streaming, nothing like that. Also have a question, how does the weather impact the strength of the signal? How secure is the system from external malicious access? So those are two great questions. As far as weather impacting the strength of the signal, it does have an impact. Weather will impact its ability to transmit. However, it's usually not very significant. Physical barriers, most notably trees and tanks, are really the two things you got to watch out for. The other warning I would have is keep an eye out for intermittent interference. Like when you install this, you have direct line of sight and everything's looking great, but then you forgot that at 7 a.m. you got 7 trucks rolling into the facility that park right in that line of sight. Things like that. Or you're installing it in the winter and there are no leaves on the trees, but in reality, you're shooting it through a whole tree line when the spring comes and the leaves grow back. Those kinds of things are much more of a hazard than you're going to find rain or snow is. Now, that doesn't mean to say if everything gets iced up and everything gets covered in snow that you may not have a problem if you're kind of pushing the range. But I don't think thus far I've ever run into one application where the weather was actually the thing causing a problem. As for how secure is the system from external malicious access, I consider that to be one of the strong points of this system, because we are using a proprietary 900 megahertz signal to transmit this. It's 128-bit AES encryption, and it's a frequency hopping spread spectrum signal, so it's not just sitting on one frequency to constantly barrage. But most importantly, okay, those are all nice little buzzwords, but most importantly, it's not a Wi-Fi signal, it's not an Ethernet signal, it's not wireless HART that everybody's real familiar with even, it's not any kind of sort of general in-use signal, right? We're not using some kind of open architecture device that somebody could try to hack into, like you might hack into somebody's network. Could you gain access to this somehow? I mean, I suppose anything is possible, but it's not going to be something you're going to be able to do without a real dedicated effort. And at best, I think you'd probably find someone able to just spam out 900 megahertz range noise and cause problems if they were really looking to be malicious. But that's not quite the same thing as gaining access to your signals, sending false signals, things like that. And if somebody does do that, if somehow you get your 900 megahertz bands blocked, you'll probably have other equipment that'll be affected. And we have a loss of signal indicator that then can give a hardwired signal to your PLC or to your SCADA system to say, hey, we've lost our connection. You should look into this. Last question I've got at the moment here is from Bob, who's asking, is there a 4 to 20 milliamp output for HART? And the answer to that's no, there is not. We don't disrupt signals that are HART, but we don't transmit them wirelessly either. So let's say you have a 4 to 20, let me find a screen here. Drawn. So let's just say for a minute, I have a tank over here and I have a HART level transmitter on the top of that tank. And I've been asked, why am I drawing everything in purple? I don't know, but we'll change colors up for you if that would make it better. So let's say you got a wireless transmitter on top of that tank, comes down the bottom here. I've got a display showing me some information. And then somewhere, up on top of this tank, I have my wireless transmitter. So let's just say real simple, that's my 4 to 20 milliamp loop. And then through the magic of wireless, that transmits over here to another field unit that goes into my PLC. Well, I'm not transmitting the HART wirelessly, right? So the HART's not going to cross that wireless bridge. But if I want to come up to it in the field and some maintenance technician or whatnot decides that they want to clip on leads here and they want to use their computer with HART info on it or use their cell phone with a HART adapter, they can certainly do that. The HART signal is going to be perfectly valid out in the field in this 4 to 20 milliamp loop, but it's not going to wirelessly transmit back here. I can't clip on over here and use my HART signal from the control room. That the HART does not go over that wireless bridge. Hopefully that's a good example, or hopefully that's a good explanation that tells you what we can and can't do with HART. So we don't blow up the signal in the wired HART loop, but we also don't transmit. So let's take a look at some simplified applications just to give you a little bit better idea how these signals are all working and wired up. So this is what a PDW30 system would look like, just monitoring one tank. A PDW30, unlike a PDW90, just comes with 2 already paired up field units. These work pretty much right out of the box, unless you have multiple systems in your plant, in which case you have to change one setting, just to change them to a different network ID. These are paired up and ready to go. You just bring your wires in and stuff works. And so what a PDW30 system looks like in this case is I've got my field unit installed at my tank. I've got my 4 to 20 milliamps coming in. That then gets transmitted through the magic of wireless over to my primary unit, where it comes back out as a 4 to 20 milliamp signal, which in this case, we're just displaying on a loop powered indicator. Now it's a great loop powered indicator. It's got an awesome display on it. It's got a red backlight. It's got relays designed into it, even though it's loop powered. But that's all I'm going to do for my control element is I just want to have a panel meter doing some simple control. I'm not really interested in bringing this into my PLC. What I do want to do here is send my loss of signal connection over to the PLC. So that contact closure will let the PLC know if something goes down in this system. Now you may remember I mentioned these are transceivers. The signals can go in both directions. So I've got relay outputs coming from my loop powered meter into my primary unit, where again, it's transmitted via the magic of wireless. And those relay contact closures come out to turn on some lights and horns in the field, alerting them to high and low alarms. What you don't see here is power. And it's worth noting that obviously these light and horns are going to require power. So I'd have 24 volts in this loop that the relay is closing, powering those. And also the wireless units themselves run off of 24 volts DC. So these are not battery powered. They certainly can be solar powered if you have a solar system, but we don't offer that. We offer these 24 volt powered. That's what you have to have available. So I need to have 24 volt power in the field to do that. Now, getting a little more complicated, let's take a look at what it would look like if I wanted to monitor 4 tanks. And to do this, I've cleaned it up a little bit. And we're talking about just the 4 to 20 milliamp input signals coming from the transmitters. So we can talk more about what it would look like in a minute if we added more. But let's say we wanted to monitor 4 tanks. In this case, I've got each tank having a 4 to 20 milliamp level transmitter on it, which sends its signal up to the field unit. Then that field unit is going to transmit that information over to our base station. And now we're talking a PDW90 system, because a 90 system is a point, meaning my base station over here, to multi-point system. It's connecting up to all of these field units. So it's a single point connecting up to each one of these field units directly. Now that my 4 to 20 has come into the field unit and been transmitted over to my base station, the base station is then going to put that out again as a physical 4 to 20 milliamp signal. And in this case, we're bringing that into a consolidator plus, sort of like we did in that second application example. And that's going to happen for each one of these signals, right? It's going to come in as a 4 to 20 milliamp signal. It's going to be wirelessly transmitted to the base station. And then it's going to come out of the base station again as a 4 to 20 milliamp signal. And one of the things I love about this system is that, and this is true for the Modbus part of this as well, if I was using RS-485, to the consolidator, it has no idea this is a wireless system. It knows it's getting 4 wired 4 to 20 milliamp inputs. To the level transmitters, it doesn't care that this is a wireless system. They're just outputting their wired 4 to 20 milliamp signals. All we do is bridge the wire through a wireless connection. And that's why we call this a 4 to 20 milliamp wireless bridge. Now, if I wanted to, I could certainly send signals back into a base station and have them come out of those field units. But in this case, I've selected a base station that only has 2 slots for modules, our smallest base station. And that's what these little squares are here. And each one of those slots is capable of putting a number of different modules in it. In this case, we're using 2 times 2 analog output modules. So 2 modules with 2 analog outputs each. That's my 4 to 20 milliamp outputs. So in this case, if I wanted to send signals back out to the field, I need to upgrade to a larger base station. So let's take a better look at the products, just so you're a little bit more comfortable with some of the things I've been throwing around here. Like, what is a PDW30? Well, the PDW30 is our point-to-point wireless bridge. You have a point and another point. And these come pre-connected, pre-talking to each other. You buy one part number, you get both sides of the unit. You get both of these devices you see here. Virtually plug and play right out of the box. Each one of these units has a 4 to 20 milliamp input, a 4 to 20 milliamp output, 4 digital discrete I/O, and an RS-485 Modbus connection on it. So it can have 4 to 20 milliamp coming in, a 4 to 20 milliamp coming out, a couple of digital I/O coming in, a couple of digital I/O coming out, and your 3-wire RS-485, all on one unit that gets transmitted back and forth from the other unit that has the exact same thing on the other side. So whatever goes into one comes out of the other. This is your simple one transmitter choice. You want to put in a level transmitter somewhere. You don't want to have to run wire to it. You want to replace a flow meter, but you really don't know where its wires go or why the signal's not working right. Like, great, just plop one of these down. They're pre-connected. You get your wireless signal. Extremely easy. Almost no programming involved in this at all. Then you've got your PDW-90 system. That's your point to multipoint. The point being your base station, your multipoint being wherever you install your field units. You'll notice, by the way, we haven't really talked about it, but there are stainless steel versions of this as well. That's worth noting. So in a PDW-90 system, you get a base station, and there's versions of that that hold 2, 6, or 16 modules. And if you look at the picture of the largest one here, you can see that we've got 4 modules installed in it. And then we have a bunch of empty slots that we can install additional modules in later. Each one of those modules can be a dual analog input, a dual analog output, a dual relay, or a 4 digital I/O module. And so that's why I say, well, how many can you support on here? Well, if all I'm doing is bringing one 4 to 20 milliamp in to a field unit, well, then I can fill this whole thing up with 16 dual analog output modules and have this outputting 32 4 to 20 milliamp signals coming from 32 field units. But if I was taking in, let's say, a 4 to 20 milliamp signal out of each one of these, and I had 2 discrete inputs coming into each one of these, well, now I'd have to do a whole row of analog outputs, a whole row of digital outputs, and now I'd only be supporting 16 field units. So really the limitation is how many different configurations or how many different locations worth of I/O you can fit in your base station. And if that's not clear, please feel free to ask a question about it. It's also worth noting that there is free configuration software for these products. And with a PDW-90, that is what you have to use to set it up. They come with a USB port right on there. So you just plug it in and use the free configuration software to connect up and program up which of your modules is looking to which of your field units, etc. It's not particularly complicated to do it. We get surprising a few tech support calls on it, but it does require some setup, which is more than the PDW-30 needs. One question that often comes up is, how do we go around a tank, or how do we go around a tree if we have to? Can we extend our range? And one way to do that is with a PDWR repeater. It looks just like the field units or the PDW-30 pair, except there's no I/O here. None. All this does, it has no I/O. All this does is extend your range. So you've got a PDW-30 unit, you've got a PDW-30 unit, but instead of having 1 mile outdoor line of sight, you've got, let's say, 1.5 miles, right? So now I've got a problem. They can't actually reach each other. Well, you put your repeater in the middle, and that's just going to add you another transmission hop. So now all I need to have is less than 1 mile to the repeater on each side, and now I can make this connection. Common question with repeaters is, how many can I fit? And I usually recommend no more than 3, maybe 4. You start getting more than that, you're going to be seeing some real significant delays. So that's my suggestion, is try to keep it to under 4 if you can. 4 is passable, but beyond that, you get some noticeable impacts on your system. But most of the time, people just need 1. They're just using it to extend their range a little bit, or to go around some really difficult obstacle. In a previous presentation like this, I was asked, for example, about a landfill, and they wanted to get a signal from one side of the landfill to the other, but there's a landfill hill in the way. And transmitting through earth is about the worst thing you could possibly try to do. And so to do that, they used repeaters to bounce it around the hill with a couple of repeaters. Seeing the accessories can also help you understand how they work. So this is our PDW-M2RY relay module. This goes in the base of those field units. And the field units all have 2 digital outputs and don't need this unless you really want mechanical relays. If you want a real relay that's going to support some significant current, then this is the module you would put in the bottom of that field unit to take in those, digital outputs from the field unit. There we go. And output those digital outputs instead as actual dry contact form-A relay closures. These are what your PDW M90 modules look like. Your dual analog input, dual analog output, 4 digital I/O, or dual relay module. These are what snap into the base station bottom, so the board in the back of the base station, in order to populate it with the I/O you need. You saw some Yagi antennas earlier. We've got 6 dB and 9 dB Yagi antennas. We want to extend your range. Keep in mind, of course, that they are limited in direction. A Yagi antenna is a very directional antenna. I think it has like a 15-degree range of fire, so to speak, that you have to keep everything aligned in. So there's applications where they're useful. There's applications where they're not so useful, but there are times where they could be helpful. And we do ship them with everything you need to mount them and such. And then you just need to buy your antenna extension cable. And we have a pipe mounting kit for the field units as well. Sometimes the only thing you have to connect to is a big grounded pole, and you really don't want your antenna to be 1/2 inch away from a large grounded pipe. And so if that is all you have to work with for mounting these, we offer some offsetting pipe mounting kits. If this was just a plastic pipe, well, I could mount it using the already included in the enclosure mounting flanges. But if I want to mount it onto a big grounded pole, well, I'm going to want to use one of these plates to offset my device so that it's not just sitting there right up next to and parallel with a big grounded metal pole. There was a question about survey kits earlier. Happy to talk about those. So we do offer a PDA 10 wireless survey kit you can buy from us, and when you're done using it, just return for credit. And what this is it's 2 handheld units that use the same communication method, the same power, the same antenna capabilities as the actual PDW30 and PDW90 units. Except here, they're small, they're handheld, they're powered by a couple AA batteries, I believe. And it might be a 9-volt, so don't quote me on that. And you put one where you want to send your signal to, and you walk around with the other one. And it'll give you its information on how well it's connected. Is it signal high or low? What's the actual percentage? And you can see where you lose your signal and where it is fine, to get a real sense of how much distance you can get or where exactly you should be mounting these things. If you're only trying to transmit short distances, you really don't need to do this most of the time, but some people feel it's just are more comfortable with these systems having done this. And obviously, if you're pushing the limits of what it can do, if you're transmitting through something like a building or trees that gives you pause, this is a great way just to see if they're going to work for you. I'm going to pause here and just address a couple of questions folks have. One question is there a battery power option available? And unfortunately, no, there is just the 24-volt DC powered option. There are ways to do this with batteries and solar kits, etc. But those are something you would have to talk to an integrator about. We don't do that. We just offer it 24-volt powered. And then someone's asking, Theory's asking, are those accessories needed? Do we need to order the accessories as additional products when we buy a PDW wireless system, or are they included in the system as default? So when you order a system, if you're ordering a PDW30, you get both of these devices, and in theory, that's all you need. When you order a PDW90 point-to-multipoint system, you have to order the base station, however many field units you want, and your I/O cards all separately. And then if you want a repeater, or you want the relay modules, or you have to buy those I/O modules separately. The antennas would be separate, the mounting kits would be separate. So generally the accessories are all separate, but the only thing you need is, if you're buying a PDW90 system, you're going to need to buy the field units, the base station, and the cards you need, the modules you need, in order to make that system what it has to be for you, because there's just a lot of options there on what it could look like. Interesting question from Khalid. How do we protect against lightning strikes? Well, the honest answer is you probably don't. If you put this antenna up somewhere and it is the subject of a lightning strike, you could try putting some lightning arresters on there. You know, there are things out there like that, but most likely these things are just going to get fried. That is the sort of truth of that. Most likely everything connected to whatever wire is struck is going to cook. Lightning is a real problem to deal with. And there are lightning arresters out there that protect systems. But if this is the direct subject of a lightning strike, and it gets beyond whatever grounded lightning rods and things like that you already have installed, then that's probably the end of at least this piece of your system, and you'd have to replace it. Also, I have an anonymous question here. Someone is asking if I can include some price information. So happy to talk about that a little bit. So generally what you're going to find is that the PDW-90, the PDW-30 all come out to be, I want to say roughly $700 a point. And to show you how I'm doing that math, I'm just going to bring you over to predig.com. So if we go over to precisiondigital.com, here's my Precision Digital wireless systems. And you can see the various different kinds of systems we have, the 30 and the 90. If I go click on the PDW-30, there's only a few different versions of it available. I'll grow this a little bit so you can see it. The one that most people are going to get is this PDW-30 aluminum pair. And that's $1,600 for the matched pair. And by the way, we have 8 of them in stock. And if you needed more than 8 or we didn't have any, we can build more in 5 days. Predig.com shows you the pricing. It shows you the lead time. It shows you the stock. And it's all live, correct information. We update this every couple of hours. This stock was just updated, for example, today at 11:17. And so this is accurate to what our availability and stock levels look like. And so, okay, in this case, you're talking $800 per point because you have 2 points on a PDW pair. That's roughly what you're going to see for the PDW-90 as well. Now that varies depending on which modules you're talking about. It goes down slightly per point as you add more points because the base station would be in theory divided out through all your number of points, but that's going to be roughly what you're looking at. And compared to the price of doing the electrical work and the construction that might be needed for some of these signals, it's a steal. Now, there are also a few other options here. You can get it with M20 conduits instead of 3/4 inch conduits, and you can get it in stainless steel if that's an environment where you need to have stainless steel because you're worried about salt exposure or really corrosive chemicals. And obviously that increases the price and thus the price per point. But if you're in a quote unquote normal, I'll call it, environment where an aluminum 1/2 inch NPT connection is all you're looking for on these field units, then you're talking about $800 a point. So if you're liking what you're seeing and you want to learn more, you can certainly visit the white paper itself online. Just go to our website, predig.com/go wireless, or do a site content search for wireless. We're happy to send you print copies. You can do that right in the survey. In fact, there was a way to do that right off the email that got you signed up for this webinar as well. And we have a video that walks you through the PDW products front to back in a relatively short period of time. And when I wrap up here, I'm happy to play that video for you. So if you want to learn more, you can stick around and watch that video play. But if you want to find it on your own, you can do that too at our website or even on YouTube. With that, I'd like to thank you for all your time. You've been with me now for almost an hour. I hope it was a valuable use of your time and you can see some applications where our wireless systems might really help you out. I'm going to go ahead and play that video for you, but I will, in parting here, remind you about the survey. If you see that survey pop up, I would love for you to take that. So with that, I will leave you with this video, which will walk you through all kinds of information. Oh, played it a little early. With that, I'll leave you this video, which will walk through all kinds of additional information about the PDW-30 and the PDW-90, let you see a little bit more of it. And again, if you get any questions when you're done watching this, don't be afraid to reach out. Thank you very much. Have a good rest of your week, folks.
Precision Digital's simple point-to-point wireless system, the easiest way to get your process signals from point A to point B. Precision Digital's wireless products give you a simple, straightforward way to get an analog, discrete, or Modbus signal from where you have it to where you need it. There's no need to run hundreds of feet of wires throughout your industrial plant. You'll save on time, manpower, and cost by simply connecting up your transmitters and control room to a Precision Digital wireless unit. With a range of 1 mile line of sight outdoor and 500 feet indoor, it's never been easier to get your critical process data from where you have it to where you need it. Whether you're retransmitting process signals from a large tank to a more convenient location, or from multiple tanks to a control room, Precision Digital wireless units can deliver your data where you need it most. The PDW-30 is a simple point-to-point wireless bridge that includes a primary unit and a secondary unit, each with analog, digital, and RS-485 Modbus inputs and outputs. It also includes a loss of signal digital output. An optional relays module with 2 Form A relays is also available and is easy to install into the base of the enclosure with the 4 screws provided. The display module is designed for convenient access to the electronics and includes removable connector plugs for easy wiring. The module snaps back into place with no screws necessary. The PDW-30 units feature a NEMA 4X IP68 cast aluminum or stainless steel enclosure with a flange for wall or pipe mounting, a remote or attached antenna, and a range of 1 mile line of sight outdoor and 500 feet indoor. This makes the PDW-30 ideal for wire replacement in rugged industrial areas. Easily program non-advanced settings on the PDW-30 using the 4 cap touch buttons. These behind-the-glass buttons allow for operation of the unit without removing the enclosure cover. For all advanced programming, use the free PDW Manager USB programming software. The PDW-30 is virtually plug and play right out of the box. All you need to do is take it out of the box and connect the power, and you'll see the primary and secondary units are already paired and ready to go. In this application example, the PDW-30 wireless bridge is being used for monitoring the level in one tank. The 4 to 20 milliamp level transmitter on the tank is connected to the analog input of the secondary unit. The milliamp signal is transmitted to the primary unit. The primary unit's analog output is connected to the PD6602 loop-powered meter, which displays the 4 to 20 milliamp signal as volume in gallons. The PD6602 is programmed to indicate an alarm condition when the level exceeds 7,000 gallons as displayed on the meter. Relay 1 on the meter connects to the digital input 1 of the primary unit and transmits the signal to the digital output on the secondary unit, which triggers the high alarm. The PDW units feature a loss of signal digital output, which alerts another device, such as a PLC, that the wireless signal has been lost. A PDW-90 base station is the starting piece to a customizable point-to-multipoint wireless system and offers a highly flexible means of getting process signals from where you have them to where you need them. The base stations come in 3 different sizes and feature a rugged plastic NEMA 4X field enclosure, standard RS-485 Modbus, and is easily field or wall mountable. Customize your PDW-90 system any way you want it by choosing one of the base stations and installing up to 2, 6, or 16 I/O modules and up to 32 expandable field units. The modules, designed specifically for the PDW-90 base stations, are easy to install and add functionality to the wireless system. 4 types of modules are available and include dual analog input, dual analog output, 4 digital I/O, and dual relays. The PDW-90 field units, like the PDW-30 units, all have the same enclosure features, inputs and outputs, and a range of 1 mile line of sight, 500 feet indoor. The field units can also be equipped with the optional 2 relays module. The field units transmit analog, digital, and Modbus input signals from any location in the field to the PDW-90 base station. All you need to do is set up the network ID and Modbus address, and the device will transmit the signal connections wirelessly. The wireless communication between the field units and the base station is bidirectional, so completely different 4 to 20 milliamp discrete and Modbus signals can be sent from the base station to the field units. Increase your signal strength with wireless repeaters. The PDWR wireless repeater is incredibly simple to install and makes a great accessory for the PDW-30 and PDW-90. These can be used if you are having connectivity issues or want to broadcast over long distances and around permanent obstacles. All units have a range of 1 mile line of sight and 500 feet indoor. In this application example, the PDW-90 wireless system is being used for monitoring the level in 4 tanks. The level in each tank is measured by a 4 to 20 milliamp level transmitter that is connected to a PDW-90 field unit. Each field unit wirelessly transmits the 4 to 20 milliamp signal back to the base station. The base station is equipped with 2 dual analog output modules that send the 4 to 20 milliamp signals to the Consolidator Plus controller. Check your signal strength before you install. The PDA-10 Wireless Survey Toolkit will help you get an accurate reading of your wireless signal strength, saving you time and cost. The PDA-10 can also be used to troubleshoot connectivity issues. Go wireless with Precision Digital and see how easy it is to get your critical process data from where you have it to where you need it. For prices, product, and stock levels, visit predig.com/wireless products.